We'll proceed in pseudo calculus problems. Okay, pseudo calculus problems. I believe that it is all right. People understand now that what is concept of repeated summation bringing into integral calculus. Generally, what we have seen, and we will see, we will take other examples also, and we will see. What we will see is that how simply, if anyone is solving a problem, then he does not know that he can use vector or he can use algebra, he can use calculus. On the way, if someone is tackling a problem, he can start tackling the problem through a simple numerical way. Everyone is deft in calculating, solving a mathematical problem through numerical way. And then slowly, once he proceeds, then suddenly he feels that, okay, now limitation has arrived. Now he has to proceed in different manner. Then he can use algebra. Then he proceeds. Then he thinks, looks like it is really difficult. Then he can use vector and calculus. But fundamental is when he feels that he need to use calculus, then he should not restart solving the problem. Wherever he is, from there, he can change his mathematical computation to calculus. That is the concept, that is pseudo calculus problem. Like someone is calculating and then all of a sudden he thinks that it is not solvable, then wherever he is seeing differentiation, he can convert it to differential calculus. Wherever he is seeing integration, multiplication, that he can convert into integral calculus. Anyway, that is the concept. Or wherever he is seeing summation, then he can convert it to integral calculus. Right now, we are focusing on summation that can be converted into integral calculus. Can a summation be converted into integral calculus? So that is the area in which we are doing, in which we are pursuing. Like someone is trying to calculate area of a circle, then the first thing it will come to his mind is height by width is the area. If I'm trying to calculate area of any 2D shape, then height by width is the area. He can proceed with the height by width. If there is a circle, okay, if there is a circle, if there is a circle, then how he can find area? Area of any 2D shape is height by width. Height by width. What is height here? If he considers this as a width of the circle, if this is the width of the circle, then this is the height. What I'm trying to say is, consider this circle is centered at the origin. Okay, consider this circle is centered at the origin. The circle is centered, consider this circle is centered at the origin. And then consider this as x-axis and this is y-axis, whatever it is. Consider if it was a rectangle. Consider it was a rectangle. If it was a rectangle, this is x-axis and this is y-axis. This is x-axis, this is y-axis. Or this is y-axis and this is x-axis. Okay, here this is origin. What is the area of this rectangle? Height by width or full height by width. If I multiply height into width, it gives the area of a rectangle. What about the area of the circle? Now I wrote, one time actually I was seeing the area of rectangle and I remember that calculating the area of rectangle is y into x. Y is height and x is width, y into x. Suddenly I saw one problem. What is the area of the circle? Then I wrote y into x. Now rectangle was centered at the origin. The circle is also centered at the origin. this is x-axis, and this is y-axis. Now I wrote y by y into x, height into width is the area. I wrote height into width is the area. Height, if this circle is radius is a, then height is 2a, width is 2a. What is the area of circle then? Y into x is the area. I know it. It is 2D shape. I know it. Y into x is the area. Y is 2a and x is 2a. 2a into 2a, 4a square is the area. Hope, but that is not true. Where I made mistake. Should I start from the beginning? Not required. Y by x, when someone is saying that is all right. After that, substituting the value of y by x, there is problem. So we can start with the pseudo code only, abstract code only. Now I know what is difference between rectangle and circle. Rectangle x-axis is there, and then if I see y-axis, then y-axis is constant in rectangle. If this is the rectangle and this is x-axis, if I move along x-axis, height is everywhere same. Y means height. Everywhere height is constant. It is not varying. But if I see circle, then if I move along x-axis, if I move if I move along x-axis, then height is varying. Okay, everywhere height is different. Certainly there is a difference. Now I cannot substitute y into x as the area of circle. Height is variable. Their height is constant. Okay, if height is variable, y into x, one in multiplication, one is variable, one is dependent upon other. Y is changing if I change x. Y is dependent upon x. Now I have to transform it into the calculus. Y into x will become y into dx. How much? Where from where x is? X is minus a to a. Then I have to write limit minus a to a, that is x. Y into dx. This is the area. Okay, so multiplication turned into integral calculus. What is other way of calculation area of the circle is? Area of the circle calculation is considered this is x-axis, and I have a radius x-axis, and I have a radius. This is centered at the origin. I have a radius, and radius is moving like this. If radius is moving now 90 degree, 180 degree, 270 degree, 360 degree. Now from here to here, it make one section. From here to here, it make one section. If I divide into n section, then if I find area of all n section and add it, then again I get the area. This is called summation, repeated summation, whatever come to someone's mind. Means we are dividing our problem into many sections, and each section I get the solution and then I add it. This is also a way to proceed in the solution arena. Now for this area, we find if this is the first section, if this is the first section of the circle, second section, third section, nth section, ith section. This is the ith section of the circle. Okay, what is the area? What is the area of the ith section? That is capital A subscript, bottom right, small I. AI is the area of this. Then what is the area of full circle? Summation mark I equal to 1 to n AI. If I keep adding AI where I is 1 to n, then all AI if I add, I get the area. Summation I equal to 1 to n capital A subscript I. Okay, I believe it is all right. Again, means this is the scenario calculating the can. Now if I convert y into x to y dx, y into x simple multiplication, it got converted into integration, that is y dx. Similarly, can I convert summation mark I equal to 1 to n ai into integration? Why you need that? Anyone would ask why you need that. Okay, you can calculate the sum, you can calculate the area like that also. Divide into n part, divide into 10 part, and then you calculate the area for each part and add it. No, there is problem. What is the problem? If I try to calculate the eighth section area, eighth section, then typically while calculating that, there is no way I can calculate the AH section area of the circle because this is the arc. Okay, this area I don't know. I can take this arc into consideration as a straight line. If I take as a straight line assumption, then in that fashion, this length into this will fall as a 90-degree on this line. This straight line will fall as 90-degree on this line. This arc length and arc length into this length by 2. This will be the area of a triangle with angle delta theta I. Okay, then what is the length? This is R and this is R. R into delta theta I is the arc length. Now R into R delta theta I by 1 by 2. 1 by 2 R square delta theta I is the area of the section of the circle, ith section, provided assumption is this arc that is passing like this, it is a straight line. This is assumption. And this assumption will be very perfect if I divide into n part where n tends to infinity. If n tends to infinity, then the angle between it, that is delta theta I, is extremely small. If it is extremely small, then I can assume that this is a straight line. But if delta theta I is big, then r cannot be considered as a straight line. But if delta theta is extremely small, I can consider this r as a straight line. Means I want summation of I equal to n, I equal to 1 to n, where n tends to infinity, and ai. If ai, ith section area was perfect, without any assumption at all, we don't need calculus. Mind it. Where we need calculus, where we don't need calculus, that is a big debate now. We need calculus where we need assumption in the summation. If I am making summation I equal to 1 to n, and then we are summing all area. In each area, if there is assumption I have made, assumption is delta theta I is very small, so arc will be a straight line. In that fashion, n tends to infinity. If this kind of assumption we are making and n tends to infinity, we have to calculate infinite summation of area. In that fashion, we go with the calculus. So this repeated addition will convert into integral calculus. Anyway, but you said that multiplication get converted into integral calculus. Repeated addition, usually it comes to multiplication arena only. 5 plus 5 plus 5 plus 5 4 times is 5 into 4 only. Means repeated addition we can convert into integral calculus. Okay, it gives perfect result because n tends to infinity. If I chop the circle into n different parts, then when if n is infinity, if I chop the circle into infinity parts, then repeated summation of all the parts will convert into a circle. It won't be a discrete value. It will become a continuous if n tends to infinity. Anyway, we are in phase of calculating the length of, okay, so we will come back to our original problem. Okay, what is the original problem? The original problem is that we are in phase of calculating the average length of a stick. Consider this is what example we have been taking. Hop. Okay, not able to add, not happy with me. Anyway, okay, consider that I have a stick. Oh, edit. Consider I have a stick. This is 1 unit length. It can be 1 meter, whatever it is. It is 1 unit length. Now this stick, I can break into two parts. Consider I am breaking this stick into two parts. I break it into two parts. Okay, consider I have a stick like this. This is of 1 unit length. This is a stick and it is of 1 unit length. Okay, I'm closing my eye and I'll break from anywhere. I'm closing my eye and I'll break from anywhere. I'm breaking from here. Okay, I broke it into two parts. Okay, now this is the smaller part and this is the larger part. Now, if I have a stick of 1 unit length, I have so many sticks of 1 unit length kept here. I take one, break it into two parts. The smaller one I throw it out, and the larger one I keep it. Okay. Then I take another same length stick and then I break into two parts. Larger one I keep it, smaller one I throw it. Now, if I take out all the larger one that I have collected, and if I try to calculate the average length of the larger sticks, then what will be the average length? That is the question that we are pursuing. Okay, there are many things hidden in this question, probability, statistics, many things hidden in this solution. That's why we are proceeding for, I believe, for the past three videos. Anyway, now 2 3 sessions. Now anyway, now in that fashion, now the idea is, if I have a stick like this, if I have a stick like this, I can break a stick. This is, consider this is middle. I can break the stick prior to the middle. I can break the stick after the middle. Means I can break the stick. If this is the stick, then I can break the stick prior to the middle, or I can break the stick after the middle. If I break the stick prior to the middle, then second half is what I'm going to collect. If I break the stick after the center, middle, then first part I'm going to collect. Now, whatever I have collected, the larger part, what is the average length of the larger part? That is under question mark. There are two ways to see it. One is I try in discrete manner. Discrete manner in the sense, now the problem, if I have, then problem I divide into n part. The way we take the circle, we divide it into n part. So now I am going, if this is the stick I am going to break, then consider this stick, this is of 1 unit length. This stick I am going to break into n part. N part. N. Okay. N can be 4, 8, 16, 32, 17, 16, 18, 19, whatever. It is a integer, not float, integer. Now, if that is the case, if that is the scenario, I break into n part. Now, this is first part, second part, third part. This is the nth part. Okay, in that fashion, now if I break, I have to break in one of the part. Out of n part, I have to break in one of the part. If I break in one of the part, then wherever I break, now consider I am breaking in the ith part. There are n part, first part, second part, third part, fourth part, ith part, nth part. Now I am breaking in the ith part, where ith part is is after the half. Ith part is after the half. If I in ith section, if I break it, what is the chance that I'll break in a particular section? There are n sections. What is the chance of breaking in a particular section? Same chance, same probability. There is no difference in probability of breaking into any cutting into any of the section. There is no preference out there. Okay, in that fashion, if there are n part and then hitting into a particular part, what is the probability? 1 by n. In that fashion, the probability of cutting in the ith section is 1 by n. Make sense? Okay, I am repeating it. From here only we will proceed in continuous. There are many things here. Anyway, now cutting in any of the section, the chance of cutting in any of the section is 1 by n. Now how I can proceed? We have already given examples of the marks. Consider that there are 10 students in class. There is a class and there are 10 students. 4 students get 50% mark. 50% mark. Out of 100, they get 50 marks. Okay, in that class, 3 students get 60 marks. 1 student gets 70 marks and 2 students get 40 marks. What is the average mark secured by the student? That is the question. Okay, if I consider this x-axis as, or stick, x-axis as the mark section and y-axis is number of a student secured the mark. Okay, in that fashion, if if now if I if someone is getting marks in 1 someone may get 51, 52, but not in float, not in decimal number. All are getting integer only. Means I have divided this mark section into 100 parts, knowingly, unknowingly. I have divided this mark section into 100 parts. First part, second part, third part, 40th part, 50th part, 60th part, 70th part, like that 100th part. In 100 part I have divided. In that fashion, in the 50th part, there is a bar that 4 students have got 50 marks. If this is the number of a student, y-axis, and this x-axis is marks, then in the when marks is 50, in the 50th section, I have divided into one mark section. I have divided into 100 section where one section width is 1. Okay, like that stick I had divided into n section. Then every section width was 1 by n. Okay, now here every section width is 1. In the 50th section there is a bar here, length is 4, means 4 students got 50 marks. 42, 63 and 71. Now, if I consider that I have to draw the bar in probability, not in the number of students, then how many students are there? 10 students are there. What is the probability of getting, if 4 students out of 10, they got 50 marks, then against 50, I draw a bar height 4 by 10, saying 4 by 10 is probability. 4 out of 10. If I say 4 by 10, so everyone will ask, what is 4 by 10? If you draw a bar 4, I understand 4 students got 50 marks. If I draw a bar at 60 and height as 3, then anyone will understand that 3 students got 60 marks. What is 3 by 10? 1 by 10, 2 by 10. 50 marks, 4 students got 50 marks out of 10 students. That is the probability. What is meaning of probability? Meaning of probability is if I sum all the bar, it should become 1. Because if I sum all the probability, it will become 1. Consider that I have a coin. Consider I have a coin and it can flop, it can flip head or tail. Consider the probability of getting head is 7 by is 0.7, and getting that means coin is biased coin. Okay, getting the head probability is 0.7, getting tail probability is 0.3. Now from here I draw, consider tail is 0 and head is 1. Now this is x-axis. Now this length is, consider this length is 2. Now 0 to 1 section is for tail and 1 to 2 section is for head, or this is the 0 mark and this is the 1 mark. Okay, in that fashion at 0 the probability is 0.3 tail. At 1 there is another bar, probability is 0.7. If I add these two bars, because these are probability bar, if I add these two bars, it should become 1. Okay, you have any another example? Consider I have two coins, I throw it. Okay, what is the probability that I get no head, zero head, means both will be tail? That is 1 by 4. Getting both zero head, number of head is 0, 0, number of head is 0, probability is 1 by 4. Number of head should be 1, then probability is 1 by 2. Number of head should be 3. Hope, I'm sorry. Consider that I am flipping 4 coins. I have 4 coins, I am flipping 4 coins. Okay, 4 coins. What is the probability that I get no head? 4 coin I have, and I believe it. Okay, let's have 2 head, 2 coin only. I believe it will be difficult. I have 2 coins. What are the probability I can see? If I flip 2 coins, probability that there won't be any head. There is a probability that there will be one head, and there is a probability that both will be head. That's it. So when there is no head, probability is 1 by 4. If there is one head, either of them can be head. Probability is 1 by 2. If both are head, probability is 1 by 4 again. If I add all 3 bars, because this is a probability bar, it should become 1. Okay, in that fashion, if I calculate the student, then a student at 50 mark is 4 by 10, 60 mark is 3 by 10, 70 mark is 1 by 10, and 40 mark is 2 by 10. If I add all bar, it should become 1. That is the probability graph. Anyway, what is the question now? The question is, what is the average mark of the student? The average mark of a student is that if this is 40, then what is distance from origin? X, 40. 40 into probability, 40 into 2 by 10 plus distance from origin 50, 50 into 4 by 10 plus 60 into 3 by 10 plus 70 into 1 by 10. If I do this, I'll get the average mark. No, 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 but it should be like 40 into 2 plus 50 into 3, 4 plus 60 into 3 plus 70 into 1. That is the total mark. Divide by number of students. Same thing you are doing with the probability 4 by 10 and this by 10. Okay, this is called average mark. How much, if this is the marks axis, then what is the average mark? Similarly, if I'm breaking the stick from any location, this tells the length of the stick, length of the stick, and length of the stick, that is unit length, I have divided into n section, and I cut in the any ith section. What is the length of your ith section from origin? Then it is I into 1 by n, because every section length is 1 by n. Ith section into 1 by n is the length. This length into probability, that is 1 by n. If I multiply like this, then if I keep multiplying for all the sections, then I'll get the average length. Makes sense? The way I got the average mark, that is the marks into probability plus marks into probability plus marks into probability plus marks into probability. If I do like, I get the average mark. Similarly, distance from here into probability plus distance, all sections distance and probability. If I add, I get the average distance. This is what we are trying to calculate, right? Okay, thank you very much. But if now consider that I is bigger than half of this stick. If this is the half, then I is bigger than half. I falls in this section. Somewhere I am cutting it. If I miss I is greater than n by 2. If this is the first, second, third, fourth section, this is n by 2 section. I is greater than n by 2. In that fashion, what is the average length? Then it is I into 1 by n, because if I cut here, here, this is the length into probability. I by n into 1 by n, that is the height probability. That is the average length. If I is after the half, if I is below the half, then I have to take this section rather than this section. If someone is cutting here, then I have to take this section, because larger section I am taking. In that fashion, this length is I by n, then this length is 1 minus I by n. Then for first half, I have to have the length, average length is 1 minus I by n bracket close into 1 by n. What is the total average? Total average is this much, how much I have summed for all the section, and this much how much I have summed for all the section. If I add it, I get for the full stick average length. In that fashion, it will become, if I is less than half, then 1 minus I by n bracket close into 1 by n plus, if it is bigger than half cut, then I by n into 1 by n. Now don't add it, because I are different. It's not that let's solve it, because I are different. Now we can say that net average length of the stick is into two parts. If I is less than n by 2, less than equal to n by 2, then it is 1 minus I by n bracket close into 1 by n plus, if I is greater than n by 2, then it is I by n into 1 by n. Okay, thank you very much. Anyone can please watch our previous video. We tried it. For simplicity, I'll try again. Consider it is divided into 4 sections. Then first section, second section, third section, fourth section. Okay, in that fashion, we are calculating for the first section. If I calculate for the first section, cut in the first section, then this is the length I am keeping, the larger length I am keeping. So 1 minus I by n, 1 minus I is the first section, 1 by n is 4 section we have made. 1 minus 1 by 4, 3 by 4 into 1 by 4, 3 by 16 plus 2 by 16, 3 by 16. Then second section, 1 minus 2 by 4, 2 by 4 into 1 by 4. 3 by 16 plus 2 by 16. That came as average length for the first half. For second half, it is I by n into 1 by n. That is 3 by 4 plus 4 by 4. 3 by 16 plus 4 by 16. It came as 3 by 16 plus 2 by 16 plus 3 by 16 plus 4 by 16. How much it is? 3 plus 2, that means 5, plus 3, 8, plus 4, 12. 12 by 16, 3 by 4. But no one will believe on you because n can be anything. Okay, then what is the unique n I take that everyone trusts on me? N tends to infinity. Now add it. N tends to infinity. If I divide this stick into n part and where n tends to infinity, every section is as minute any can imagine. It can be picometer, micrometer, whatever it is, every section. Infinity. I divide n into infinity. If I divide n into infinity, it will tend to be a continuous function rather than a bar what we are talking 1 by n, 1 by n. It will become a continuous section. Okay, means it is now turning up into integral calculus. We have already said this. What is a discrete solution? Discrete solution is when I is less than n by 2, summation of I equal to 1, summation of I equal to 1 to n by 2, 1 minus I by n bracket close into 1 by n, plus if I is greater than n by 2, then summation I equal to 1 to n by 2. More or less it becomes summation mark I equal to 1 to n by 2. Oh, I'm sorry. There in right hand side, it becomes I equal to n by 2 plus 1 to n. First one is I equal to 1 to n by 2, 1 minus I by n bracket goes into 1 by n, plus when I is greater than n by 2 means summation mark I equal to n by 2 plus 1 to I equal to n, I by n into 1 by n. This one will transform into integral calculus if n tends to infinity. Now no one dare to make infinite addition, not possible. It will turn into integral calculus if we transform it into it if I make n tends to infinity. If n tends to infinity, how we can solve it? Okay, this is the problem that we are pursuing. If n tends to infinity, then we have cut into n different part and that n different part is infinity. Number of section is infinity. If I draw a bar, then more or less all bar are very in a small manner. If they are spaced, more or less they are continuous. In that section, top of the bar, if I draw attach it, it becomes a line. It becomes a line, and more or less it will become up to here only. It becomes a line. Anyway, how I can transform, if you remember that we were calculating the area of the circle, and area of the circle, ith section area was 1 by 2 r square delta theta I. R can be function of theta also. R cannot be constant. In that fashion, it will become 1 by 2 function over theta whole square delta theta I. Summation mark I equal to 1 to infinity. That will convert into 1 by 2 function over theta whole square. Delta theta I will convert into d theta. And this is I equal to 1 to n will go away and integration will be theta will be one location to another location. This is the typical way of converting the repeated summation into integral calculus. What integral calculus talks about? Integral calculus talks about the area. If I say fx dx, integration means if this is x-axis, and fx is a function over x-axis, if I say fx dx integration sign, then it calculates the area underneath the fx. Consider this is fx. Okay, consider that this is fx. Consider this is up. Okay, consider this is x-axis and this is fx. Beyond this, forget it. Beyond this or this is fx. This is fx and this is x-axis. If I do fx dx and limit is from this point to this point, then it is exactly calculating the area underneath it. Fx dx calculate the area underneath it. Okay, how repeated addition and fx dx are associated to each other. Consider this is origin and this point is x. Consider this is origin and this point is x, or this point is alpha, whatever it is. I chop consider this is 0 and this is x, and I chop it into x part. X is 10, then I chop it into 10 part. X is 100, I chop it into 100 part. Means one section is one width. Width of one section is 1. If this length is x and I chop it x parts, the width of one section is 1. Means 1 x time becomes 0 to x. Make sense? Okay, in that fashion, if I draw a bar into every section, there are x sections, I draw a bar in every section. Forget it. I'm not talking about it. Consider in each section, I draw a bar. There are x number of bar that will come out. Now, what is the addition of all the bar? That is summation I equal to 1 to x, or I equal to, because I have divided into x part, I equal to 1 to x fx at x equal to I, xi. Makes sense? Summation I equal to 1 to x function over x at x equal to I, xi, ith section function. Means I is first, second, third, fourth up to x. Now what is the ith section height? That is fx at x equal to I, fx at x equal to I. Summation I equal to 1 to x. Makes sense? If this is alpha instead of x, then I have divided into alpha part. Make sure the distance of one, the width of one section is 1. Then summation mark I equal to 1 to alpha number of section I divided, fx I. Can I convert into integral calculus? Certainly. It will be integration side fx dx. Fx dx. Both are same? Certainly both are same. How come both are same? Okay, integration means the area. If I draw here fx, that is the height bar, fx, 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 fx. If I add all the fx, okay, rather than adding all the fx, I can read. If I say fx dx means if this is fx here and second section fx, if I if I connect all the top point, it makes a line. If I connect all the bar top point, it makes a line. If I say fx dx, we are calculating the area underneath it. But if I say repeated summation of fx, simply we are adding all the alpha bars. If 0 to alpha is the width, then if there are the bars are alpha in count, we are adding all the bars. Okay, but if I say fx dx, if I connect all the top of the bar and if I calculate the area, that is integration. But if I add all the bar, that is summation. How they can be same? Summation of I equal to 1 to alpha fx I. How it can be same as integration of x from 0 to alpha fx dx. Fx dx calculate the area, whereas repeated summation add all the bar height. How they are same? Because you calculated the height of each section where a section width is 1. Means I can say rewrite it as summation of I equal to 1 to alpha, summation of I equal to 1 to alpha fx function over x, that is the height, fx into 1, because every fx has a width of 1, not width of 1, after one section 1 fx comes. So I can multiply it by anything, I can multiply with the 1. It becomes summation of I equal to 1 to alpha fx into 1. I can write like that. 1 I can rewrite as delta x, where delta x equal to 1. Makes sense? Now it becomes summation of I equal to 1 to alpha fxi delta xi, where all delta xi are 1. This form of summation will convert into integration fx dx. What is going on under the net? If I talk about the first section, I have a bar. Then bar into 1 will give the area of this section. Makes sense? And that is same, multiply by 1. Means if I add all the area, then I get the full area, that is the integration. I divided this integral area underneath into many sections. And one section is of width 1 and height of the bar. Okay, if I have on x-axis 0 to alpha, if I have on x-axis 0 to alpha, and I divide into n part where n tends to infinity. In that way, summation of I equal to 1 to n fxi cannot be converted into fx dx, because summation of xi where n tends to infinity, there are so many bars are coming now, so many bars. In 0 to alpha, we have innumerous bars are coming. If I add all the bars, it will be far bigger than I take the area, because bars are so many. If bars are alpha in number, then I can multiply by n. So repeated summation I equal to 1 to n fxi, where n is not equal to alpha. This is the better word. Where n is not equal to alpha cannot be converted into integration fx dx, integration x equal to 0 to alpha. Not possible. Both are not same. What are same now? If I have alpha 0 to alpha and I divide into n section where n tends to infinity, then what is the same? Same is summation I equal to 1 to n fxi delta xi. This can be converted into integration fx dx where x is 0 to alpha. What is delta xi you have put? Delta xi is the width of each section, but it is very small. You have to multiply by the small only. Means one bar is coming, multiply by very small delta x, that will give this strip area. If I add all the strip area, it becomes fx dx only. Okay, but if I just write summation of I equal to 1 to n where n is not equal to alpha, and then fxi, if I do summation, then hidden 1 I can multiply, that is delta xi. This cannot become integral calculus where x is 0 to alpha, because they are not same, because the width is not 1. Delta xi width has to be 1. If it is not 1, that expression should be in delta x only. We cannot assume delta xi as 1. Make sense? Now we'll go back to our stick problem again. Now stick problem, when we are trying to convert into fx dx, what we have received right now. Consider one, we have right now summation sign I equal to n by 2. Sorry, I equal to 1 to n by 2. 1 minus I by n into 1 by n. N is the height. I minus 1 minus I by n is the distance. If this is a unit length, and if I consider this distance x, then 1 minus I by n is the x distance. And whereas 1 by n, what we are seeing is function over x, that is the height, which is constant. Function over x can be constant. More or less we are saying x into fx, summation I equal to, means xi, the length, 1 minus I by n is the length into height, that is the function over x. I equal to 1 to n by 2 x fx. Can x fx, can it be converted into x fx dx? Certainly not, because the width of each section is not 1. It should be 1. If it is 1, then we can write it as x fx delta xi, x into fx into delta xi, ith section, where delta xi is 1. Okay, but truth is that each section, the bar is representing each section, it has a width of 1 by n, not 1. It should be 1. If it is 1, then we can take it into integral calculus, x fx dx. Then boss, tell me what we can do now. Okay, then what is the concept? Concept is that if I have a section width as 1 by n, then height into 1 by n will give this area. If I add all the area, it will give the integral calculus. It can be converted into fx dx, where x is 0 to 1. If I am talking about half, then it is 0 to half. X is 0 to half x fx dx. This talks about, leave x now, fx dx. Fx dx will give whatever the fx I am taking. If I draw a curve 0 to half, the area underneath it is giving. But problem here is our height is 1 by n and width is 1 by n. Okay, width should be 1, or I have to take height in such a manner that if I multiply by the width, that is 1 by n, then it should be same. Makes sense? Okay, what I'm trying to do, if I have a hypothetical fx, then if I say fx into dx and I integrate from 0 to half, it gives the area underneath. This area underneath can be divided into n by 2 chops. This is one chop, second chop, third chop, n by 2. I'm talking about half section only. In half chop, n by 2 chop, I can divide this area fx ds. Fx is a function, true. But fx ds gives the area that I can divide into n chops, where each chop area, if I add all the chop area, then I get fx dx only. If I have one chop area, second chop area, third chop area, n by 2x chop area, if all area if I add, it becomes fx dx x equal to 0 to n by 2, half 1 by 2. Same thing. Then boss, what will be fx? That is the question mark. Since I have divided into many sections and one section is 1 by 2, then what height I take, that if I multiply this height with 1 by n, then this will give me one area. Then I multiply here with 1 by n, it will give area. If I add all the area, it will become fx dx only. Then it is possible. Now, if I watch it very closely, what is x? X is 1 minus 1 by n, I by n. In summation I equal to 1 to n by 2. I 1 minus I by n. This is x. What is fx? That is the height. Height is 1 by n. Okay, this is what we are summing. Can I convert this height 1 by n into 1 into 1 by n? 1 into 1 by n. What is 1 into 1 by n? 1 is the height and 1 by n is the width. Consider fx is 1. Consider fx is 1 and width is 1 by n. Certainly width is 1 by n only. Means if height of the bar, if I take one constant and width is 1 by n, if I multiply, it gives me the area of one strip. Then again height is 1 and area and width is 1 by n. It is giving me area of another strip. If I add all the strip, it gives me fx dx. What is your fx? 1. 1 into 1 by n. What we are trying again? I equal, this is not available in any of the book. I equal to 1 to n by 2. Bracket 1 minus I by n. Bracket close into 1 by n was there. 1 by n I am writing is as into 1 by n. 1 is new fx. Now I converted 1 by n to 1 into 1 by n is delta xi. Now 1 into delta xi gives the ith section area. If I add all, it gives me the full area, and full area is nothing but fx dx1. Okay, this proves that the new calculation where n tends to infinity, if I'm trying to make where n tends to infinity, it will work, because every section width is 1 by n and height is 1. If I multiply anything height, if I multiply height with the 1 by n, it gives me the area of that strip. If I add all the area of the strip, it gives me the full area, and that full area is fx dx1. Continue in that fashion. If now 1 minus I by n, we will turn into x from 0 to x, where x is 0 to 1. X. Now it becomes summation I equal to 1 to n by 2, where n tends to infinity. X. Fx dx, where fx is 1. Okay, dx, that is delta xi, or I can rewrite it. Summation I equal to 1 to n by 2, where n tends to infinity. And n tends to infinity and I is less than n by 2. First circumstance, 1 minus x, 1 minus I by 2 is x. 1 minus x, I've forgotten. If I break it into first up, then I have to take the length as 1 minus x. This one will be the length. If this is x, then this will be the length I have to take. 1 by I by n is 1 minus x. If I cut here and this is the x, from origin the distance will be x, then I have to take 1 by x, because longer part I have to take. That's why I did I 1 minus I by n. It becomes summation I equal to 1 to n by 2, where n tends to infinity. 1 minus xi, ith section x, into fxi into delta xi plus summation I equal to n by 2 to n, where n tends to infinity, I by n, that is x, and then fx, that is 1, into 1 by n, that is delta xi. Now if I fix it into integral calculus, it is a fit case to come to integral calculus, fx delta xi. Now it becomes integration sign x equal to 0 to 1 by 2, 1 minus x, fx is 1 dx, plus integration sign where x is 1 by 2 to 1. Makes sense? X, fx is 1, 1 dx. Now it resolves into 1 by x dx, and x is 0 to 1 by 2. If someone solve it, it becomes x minus x square by 2. 0 to 1 by 2, how much it will be? 1 by 2 minus 1 by 4. It will become 1 by 4. I believe so. It will become 1 by 4. Okay. Next is 1 by 2 to 1. X dx, x square by 2. That is 1 minus 1 by 4. So 1 by 2 to 1. X dx, x square by 2. Okay. If I put 1, it becomes 1 by 2. It will become 1 by 2 minus, and then half. Half will become 1 by 8. 1 by 2 minus 1 by 8. It will become, I believe, 8. 4, 8. It will become 4 minus 1. 3 by 8. It will become 3 by 8. Okay, let's solve it this again. Integration 0 to half. X is 0 to half. And then 1 minus x dx. It becomes x minus x square by 2. If I keep 1, then it becomes 1 minus x square by 2. I'm sorry, it is 0 to half. I have to take half. Half minus 1 by 8. 1 minus 1 by 8 again. It is again 3 by 8. 3 by 8 plus 3 by 8, 3 by 4. Okay, so solution is coming as 3 by 4. Okay, little bit will proceed on this in the next video. I'm really badly sweating. Anyway, this is the way we transform any repeated summation into integral calculus. Repeated summation can only be converted into integral calculus when there is fx delta xi, summation of I equal to 1 to n fxi delta xi, because fx dx, if I convert into fx dx, it will give the underneath area. If I say fxi dx delta xi, it gives the area of one section of that area. So if I add all the subsection, I get the area. Repeated summation I equal to n fxi may not give the integral calculus. It will give integral calculus if subsection is of width 1, then it will give integral. If width is not 1, like if I chop in n part, n tends to infinity, its width is very small, it is not 1. In that section, I equal to 1 to n fxi cannot be converted into fx dx. It can be converted to fx dx only when if I have something like this, I equal to 1 to n fxi delta xi, where delta xi is the width of one section. If I chop into n part, this will be converted into fx dx, because one part area, all part area, if I add, it becomes fx dx whole area 1. Okay, that is the way. So we had a repeated summation in the stick length. There was no delta xi. We changed the fx. Fx was 1 by n. We changed in such a manner that new fx came into delta xi. We brought into that terminology, and then it was possible. Little bit we will see the natural continuous function. This is the something that we took from some location and we brought into a continuous function, and we did the integral calculus. In probability region, what is the natural way of getting the integral calculus? That we will see. Please do. This is not available in any of the book. Anyone can try. Please do not mind supporting us. Plus, 91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India country.